Hello everyone. Today I would like to share another example on the first order LDE. Okay, the question looks like this. First, find the particular solution of the system of the first order linear differential equation is below. Consider its initial condition with y0 equal to 0 and 4 over 3. So the question for y1 prime is y1 plus 3y2 and y2 prime equal to negative 3y1 plus 7y2. Okay, how to solve this equation? How to solve this question? Okay, first of all, we have the first step. And step 1, write it in the matrix form. Step 1, you write in the matrix form y prime equal to ay. Okay, you transform all these y1 prime and y2 prime into ay. Okay, from here you can get 1, 3, negative 3, and 7. 1, 3, negative 3, and 7. Okay, then step 2. Step 2 is find the eigenvalue. Find the eigenvalue and vector. Okay, so from the matrix A, 1, 3, negative 3, and 7, you get 1 minus lambda, and 3, negative 3, and 7 minus lambda equal to 0. And then you solve. You solve this one minus this one. Okay. Alright, so you have 1 minus lambda, 7 minus lambda, minus 3, negative 3. So you have 7 minus lambda, minus 7 lambda, plus lambda square, plus 9 equal to 0. So now you rearrange, you get lambda square, minus 8 lambda, plus 16. 7, 6, so 16 equal to 0. So when you factorize it, you get lambda minus 4, lambda minus 4. So we have lambda equal to 4. This one also lambda equal to 4. Okay, so you need to find the eigenvalue. So you have a lambda equal to 4. So you for lambda equal to 4, you substitute the value of lambda. So you substitute into the value of lambda into here. So you have 1 minus lambda, so lambda is 4, 3, negative 3, 7 minus lambda, lambda equal to 4. xy, then you find what is the y value. So you have this one, and then not plus with this one. Okay, now you have a negative 3x plus 3y equal to 0. And then you have this one and this one, negative 3x plus 3y equal to 0. Okay, then you assume, so you let the x equal to s. So you have the negative 3s. Okay, we already substitute the x equal to s. So negative 3s plus 3y equal to 0. So y equal to 3s over s equal to s. So your eigen vector is equal to 1, 1. And also the second, so the second eigenvector also 1 and 1 because you have the same lambda. Right, next, the third step is to test whether it's linearly independent or not. So step number 3, since you have 1 and 1, 1 and 1, so you write down 1, 1. Okay, second one, 1, 1. Okay, so you multiply this one minus this one. So you have 1 and 1 minus 1 and 1. So equal to 0. So when you equal to 0, so this is not linearly independent. Okay, when it's not linearly independent, the solution is different. It's different from linearly independent. So we have another solution. Okay, when it's not linearly independent, then you go to the page 71. Then you assume, okay, you assume that the vector 1 x equal to e1. So you assume the vector 1x equal to e1 equal to 1 and 1. So this 1 and 1 is from here. Okay. So is the first solution. If you go to the page 71 under the procedure, here they also tell you the step of finding the not linearly independent eigenvectors. Okay, so the first step is to assume the vector 1 is e1. Okay, and then second step, is to let the a minus lambda I e2 equal to e1. Then you find e2. So you assume e2 equal to a and b. So this is a. So you write down a minus lambda I. So this is a minus 4. Lambda is 4, so 4. I. I is the identity. So 1, 0, 0, 1 for 2 times 2 matrix. A and B equal to AB equal to E1. Your E1 is 1 and 1. Okay, so meaning that this is the A minus this is lambda and this is I and then this is E2. E2 equal to E1. You follow this one. Okay. Okay, then you substitute. You solve the equation. You solve this matrix. Okay, now you have 1 minus 4. Okay, 1 minus 4 times 1. So 1 minus 4 times 1, so you have 1 minus 1, 1 minus 4. And then negative 3 minus 0, 4 times 0, so you have negative 3. So here you have 3 minus 0, and then this one is 7 minus 4. Okay, and then you copy down A and B equal to 1 and 1. Alright, so when you solve, you have negative 3, 3, negative 3, and 3. Maybe. Okay, so you have generated two equations. So negative 3a plus 3b equal to 1. This one. And then negative 3a plus 3b equal to 1. Then you assume you let the a equal to s. So you substitute the a to s. Alright, so you have negative 3s plus 3b equal to 1. So b equal to 1 plus 3s over 3. And then you assume the s, you let the s equal to 1. So you have 1 plus, this is 1. So you have 4 over 3. So your eigen vector is equal to 1 and 4 over 3. Okay, this is the first solution. And then the second solution, so C. Okay, just now you have B. And then we go to C. The second solution. So second solution, vector 2x equal to e1x plus e2. So e1 from the equation first part, e1 is 1 and 1x plus e2. Okay, this is e2 is 1 4 over 3. Okay, or you can write it in this way. Vector 2 equal to, okay, so it's 1x, so you have x plus 1, or you have the x plus 4 over 3. Okay. And now we go to the step 4. Step 4 is a general solution. Yx equal to c1 vector 1 exponent lambda x plus c2 vector 2 exponent lambda x. So c1 vector 1. Vector 1 is what? Vector 1 is 1 and 1 for lambda equal to 4. Then c2. Okay. So this is the vector 2. So this is the vector 2. So this is the vector 1. This is the vector 1. 1 and 1. So this is vector 1, this is vector 2. The vector 2 is x plus 1, x plus 4 over 3 for lambda equal to 4. Okay. Or we can write it in another way. So we have y1x equal to c1 exponent 4x plus C2. Oh, these are the C2 here. C2 x plus 1 exponent 4x. And then y2x equal to C1 exponent 4x plus C2 x plus 4 over 3 exponent 4x. Okay, so this is the standard solution. Okay, don't forget we have the step number 5 for the initial condition. Okay, so we need to find what is C1 and what is C2 so that we can substitute. So that is a function of the initial condition. Okay, step 5. Step 5, we find the particular condition we find the particular solution for initial condition y0 equal to 0 4 over 3. So this means that when x equal to 0, y1 equal to 0, y2 equal to 4 over 3. Okay. Alright, so you substitute in this value into here. Okay, let's do it. Okay, we substitute into y1 first. So you have y1 equal to 0 equal to c1 exponent. Okay, we refer to this one. Okay, exponent 0 plus c2. X is 0, so you have 0 plus 1 exponent 0. Okay, so you have 0 equal to c1 plus c2. So this is the equation. Okay, so c1 equal to negative c2. Okay, sorry. So this one is equation 1. And then you substitute the initial condition into the y2 value. So y2 equal to 4 over 3 equal to c1 exponent 0 plus c2 0 plus 4 over 3 exponent 0. Okay, now we simplify, we get c1 plus 4 over 3. So okay, you substitute the second y2, you substitute the initial condition into a y2 value. So here, so you have y2 equal to 4 over 3, 4 over 3, and then the x is equal to 0, so you get this equation, and then you simplify, you get 4 over 3 equal to c1 plus c1 plus 4 over 3 c2. So this is the second equation. Then you substitute the first equation. This is the first equation. So the first equation into the second equation. So okay, first equation is c1 equal to negative c2. Okay, so you have the c1. So your c1 is equal to negative c2. So you have 4 over 3 equal to negative c2 plus 4 over 3 c2. Okay, you will get c2 and c2 equal to 4. And then you substitute the c2 value into c1, into equation 1. So c1 equal to negative c2, and then you have a negative 4. Alright, so you know that the c1 is negative 4, c2 is 4. So now you can substitute into the c1 and c2. So last answer is y1 equal to c1. So C1 is okay, Y1 equal to C1. So it's still in here. So Y1 equal to negative 4 exponent 4x plus 4x plus 1 exponent 4x and equal to 4x exponent negative positive 4x. And then y2 equal to negative 4 exponent 4x plus 4x plus 4 over 3 exponent 4x exponent 4x plus 16 over 3 exponent 4x. So it's equal to 4x plus 4 over 3 exponent 4x. No, I think this one just enough here. Okay, so that's all for the answer for this equation. That's all. Thank you.